In this video, we're going to have an introduction to linear equations. We definitely had the introduction to algebra, where we dealt with algebraic expressions, and now it's time for us to move towards equations. All right. If I were to give a definition of an equation, it would be a mathematical statement that two quantities are equal. All right. And the keyword here is equal. We're going to start having statements where there's an equal sign. That means we can now solve for stuff. More specifically, linear equations are equations with one variable such that the only exponent on the variable is 1. All right. For instance, we may have an equation that looks like this: x plus 1 equals 7. All right. Notice my exponent on the x, it's not, you don't see it, but it's understood to be a 1. All right. Another example of a linear equation: 2x plus 4 equals 0. That's an example of a linear equation. All right, there's a 1 on my exponent. A non-example would be one like this: 2x squared equals 7. Notice that 2 as the exponent. This makes it not a linear equation. All right, and so of course we're going to want to solve these things, but we need to make sure that we're aware of what a solution would look like. Okay, a solution, or solutions of equations, are a value that makes the equation true. Right? So if I think that something is a solution, then I should be able to plug that solution in for that variable, kind of like the evaluate thing that we did before, and it should be a true statement. Let's look at an example. In this example, it says, is x equals -4 a solution to 6x plus 11 equals -13? All right, well, I'm going to replace this -4 in for this x right here in this equation. All right, and so instead of having 6x, I'm going to have a 6 times -4 plus 11, and I want to see if that equals -13. All right, and if it does, then I'd say it is a solution. If it doesn't, then it would not be considered a solution. Well, 6 times -4 is -24. Still have plus 11 equals -13. And if I add -24 and 11, I do in fact get -13. This is a true statement, and so I say yes. -4, x equals -4 is a solution. Okay. Now, of course, we're not just going to be giving you solutions. We want you to be able to solve these equations. All right. And there's a couple of ways to solve. All right. We're going to start with basic one-step equations, and we'll move our way up. All right. To solve equations, we're going to use two tools. Our first tool is the multiplication property of equality. It basically says that if you multiply both sides of an equation by the same thing, all right, both sides means we keep that true balance, that true equality. If we multiply, then the equation is going to remain true. All right. If it works for multiplication, it does also work for division, as long as we don't divide by 0. All right. And we also have the addition property of equality that states if you add the same number to both sides of an equation, the equation is going to remain true. With that addition, notice subtraction is the adding the opposite. Subtraction can be changed to addition by adding the opposite, right? And so this will also work for subtraction, but we just don't call it the subtraction property of equality. All right. And so now that I have these tools, I'm going to use them with what we call inverse or opposite operations to actually help me solve equations. All right. So I have my addition or my multiplication property of equality. And now I want to see how I'm going to use those to help me solve an equation. If I see an addition, like let's say I see an addition in my problem, then what I'm going to want to do to solve for my variable is to do the opposite operation, which would be considered subtraction. Similarly, if my problem starts with subtraction, then I'm going to want to do the inverse of operation, which is addition. All right. The same is going to hold for multiplication. If I see a multiplication in my problem, then in order to undo that multiplication, I'm going to go to division. And if I see division, in order to undo that division, I'm going to multiply. And these things will help me solve for my variable. All right, let's look at some examples. All right, in this We have 4 examples here. These are one-step problems. We're going to get to more complicated problems as we continue studying. But let's look at part A. We have 3x equals negative 96. Notice this is a linear equation. The exponent on that variable is 1. Now, if you notice, as we look at this problem here, we see a 3 and an x. There's understood to be a multiplication between them. So if I want to solve this equation here, what I'm going to have to do is do the opposite of that multiplication, which is the inverse operation of division. So what I'm going to do is I'm going to divide both sides by 3. Notice the 3's cancel here. All right, and so I'm left with just x. And negative 96 divided by 3 equals negative 32. All right, and notice we can always check ourselves. All right, so if you want to ever check yourself, just plug in negative 32 in for x. So I have 3 times negative 32. And if that equals negative 96, then we know that we do have our correct solution. And it does, in fact, equals negative 36. So this is my solution here. Let's look at this next example. I have x divided by 8 equals 4. Notice between my variable, all right, looking at my variable, the operation that I see in the problem is division. Well, the opposite or the inverse operation to division is multiplication. And so what I'm going to do is I'm going to multiply both sides by 8. So I'm going to come on this side, multiply it by 8, and I'm going to come on this side and multiply it by 8. Notice the 8's cancel, so we're left with x. And 4 times 8 is 32. Okay, so we get x equals 32. All right, and again, you can check your solution. Since I've already told you how to do it, I won't check it anymore in this video. Let's look at some other examples. All right, in part C, we have a plus 22 equals negative 8. Looking at that variable, that unknown there, the arithmetic operation that I see is addition. Well, I have to do the opposite of the addition or the inverse of addition. So instead of adding 22, I need to undo it by subtracting 22 from both sides. All right. So I'm going to be left with a. These 22 minus 22 is 0. And when I do a negative 8 minus 22, I get a negative 30. So my answer to this problem is a equals negative 30. Last but not least, we're going to go to part D, where we have negative 13 equals x minus 28. All right, looking at my variable x, the operation that I see in the problem with that x is subtraction. And so I have to do the opposite in order to isolate my variable. So I'm going to add 28 to both sides. All right, my left-hand side, I get a negative 13 plus 28, which is 15. And the 28's cancel over here, and so I'm left with x. All right, it doesn't matter what side your x or your variable is on, as long as it's isolated. So that's the big goal of solving equations, is to isolate your variable, get it on one side by itself. And we don't care which side it is. But that's a great introduction to solving linear equations.